Hey guys, welcome back to chapter 17. What I'm going to do in this video is another problem with calculating the change in pH for a buffer. And this time I'm going to mix it up a little bit and add a base instead of an acid. So what is the pH of a 1 liter buffer that has 0.65 moles of acetic acid and 0.75 moles of sodium acetate? And it has 0.01 moles of sodium hydroxide added to it. So see if you can calculate the pH of the buffer after the sodium hydroxide is added. All right, step 1, write a balanced equation for the buffer. So our buffer in this case is acetic acid, sodium acetate. So it's going to look like this. Acetic acid reacts with water to produce the acetate ion and hydronium. If you guys are putting the salt in there, that's the sodium acetate. Okay, so there's our equation of the buffer. Done. Step 2, write a balanced equation for the addition of the strong acid or strong base. So in this case, sodium hydroxide is being added. Hopefully by now you guys recognize that as a strong base. Oops. So if sodium hydroxide is a strong base, which portion of the equation is this going to react with? Whoa. Which portion of the equation is this going to react with? Yeah, it's going to react with acetic acid, right? So the base is going to react with the acid or be neutralized by the acid. Remember, this is a one-sided arrow. So the base is going to react with the acid to produce water. There's our neutral plus that salt. So sodium acetate is coming out on the other end, or the conjugate base. Okay. Step 1, write the equation for the buffer. Step 2, write the balanced equation for the addition of the acid or base. Step 3 is going to be to calculate how this changes things stoichiometrically. So remember, this is moles before, moles added, moles after. No cute acronym for this one. And then this is the second equation. So on the top is going to be our NaOH, our acetic acid, and our sodium acetate or acetate ion, whichever one you guys are using. Okay. Moles before is just going to be the number that's given in the problem. So 1 liter buffer solution has 0.65 moles of acetic acid. So 0.65 and 0.57 of the sodium acetate. Before we add the strong acid or base, there's none of it because we haven't added it yet. Okay. Next, we're going to see how much we add. So we're adding 0.01 moles of our strong base in this case. So 0.01, and as we're pouring it in, this doesn't change, this doesn't change. Okay. Moles after, so again, all of the sodium hydroxide is going to react. To do that, it's going to use up the acetate ion. So it's going to be, whoopsies, 0.65 minus, so it's going to use up 0.01 moles of that. And it's going to create the sodium acetate. So it's going to be the 0.75. It's creating more of it, plus 0.01. Okay. So if I plug this into my calculator, we're going to have 0.65 minus 0.01. So this is going to be 0.64. And this is going to be 0.57 plus 0.01. So this is going to be 0.58. This is prettier. Okay. I'm trying, guys. I'm trying. All right. So write the equation, done. Write the equation, done. Stoichiometric calculation, done. Equilibrium calculation, or remember Henderson-Hasselbalch equation to get to the pH. So Henderson-Hasselbalch pH equals pKa plus log of base over acid. So I gave you again the Ka. So pKa is just the negative log of this. pKa equals negative log 1.8 times 10 to the negative fifth, 4.74. So equals 4.74 plus log. Right, so the conjugate base after addition is the 0.58. The weak acid after the addition is 0.64. So pH equals 4.74 plus, so I'm going to take 0.58 divided by 0.64. That's 0.90. And I'm going to take the log of that answer, and I get negative 0.04. So 4.74 minus 0.04, and that is 4.7. Great. I hope you guys found that helpful.